Assalamualaikum and hi everyone. We are from MTH3200 Group 3 and from Group Assignment Group 10. And in this video, we'll be presenting about sequence and series in cryptology and finance. But before that, let us introduce ourselves first. My name is Nur Christina binti Azizan. My matrix number is 207764. Next.
My name is Nur Izzati binti Abdul Malik. My matrix number is 208145.
My name is Muhammad Saifurizan bin Tauzam Rahman. My matric number is 208051.
My name is Ummu Zulaika binti Zulkifli. My matrix number 207513.
And I am Nurshafika binti Ibaka and my matrix number is 207725.
Okay, next. Present. Okay, so from the assignment we got from Dr. Vitriani, we must complete 6 tasks. So for the first task, we must find the sum of the arithmetic series in one donated by SN. So let's we read the equation. The question arithmetic series is a sequence of numbers which is usually adopted in our daily application. The sequence is denoted with its first term A1, common difference D, and n term. The formula to find the sequence is given as follow: an equal to A1 plus n minus 1D. Okay, so how we find Sn? So the formula is we must write the sum of formula Sn equal A1 plus A2 plus plus an minus 1 plus an. Okay, so after that we know Sn is equal to A1 plus D plus A1 plus n minus 1D. Okay, next. Okay, so we rewrite the sum in reverse order. Okay, so the sum is A1 plus n minus 1D plus A1 plus n minus 2D and so on. So now we have first term and second term. So we add 1 and 2 term by term. So for Sn equal to A1 plus A1 plus D plus A1 plus n minus 2D plus A1 plus n minus 1D. Okay, so the second term Sn equal to A1 plus n minus 1D plus A1 plus n minus 2D and so on. Okay, so and lastly, each term is the same and sign there are n of them. So Sn equal to n multiply with 2A1 plus n minus 1D. Therefore, we can get the Sn formula for arithmetic is Sn equal to n minus 2 multiply with 2A1 plus n minus 1D. Okay, that's how we got task 1.
Okay, so moving to the task 2. So encryption is a process of transforming readable text called plain text to an unreadable text called ciphertext using one or more keys. So consider the sum of the arithmetic series obtained in task 1 as the encryption equation. So we have our encryption equation, which is Sn, the Sn formula. So let alphabets A equal to 1, B equal to 2, C equal to 3, and so on until Z equal to 26 to be A for the plain text, while D equal to 14 and N equal to 3 are the keys of this encryption equation. Suppose the resultant of the equation to be the ciphertext value. So complete the table given below that shows the plain text and its corresponding value with the ciphertext and its corresponding value. So we must use the ASC2 table. So moving on, our solution. So we must make it 36 times. So every single, for A equal to 1, for B equal to A equal to 2, but for D and M is the same for all because N equal to 3 while D equal to 14. So until A equal to A until Z, which is Z A equal to 26. So for A we got Sn equal to 45, B equal to 48, C equal to 51. So after that we construct the table. Okay. So by this, we can see in this table that A, which is the plain text value is 1 and we got the ciphertext value 45. And according to ASC2 table, the ciphertext A equal to this symbol, dash symbol, while B we got 0, while C we got 3, while D we got 6, and so on until Z we got X, right? X. Yes. Back. So we succeed in complete the encryption table. So the next question given, using the completed table, encrypt the text below, which is mathematics is fun. Previous slide, mathematics is fun. So by alphabet, we translate the plain text into the ciphertext. So which is M, we got Q, A equal to dash, E equal to F, H equal to B, and so on until we got the complete ciphertext. For mathematics, it's fine. So that's all for task 2.
Okay, next for the task 3, we must find first boot it decryption function. Okay, so how we boot the decryption function. Okay, so when we can look at this example, plain text, go to encryption, go to ciphertext, go to decryption. So the formula is always encryption function. We have C equal to 3 over 2, 2A plus 28. But decryption function, A equal to C over 3 minus 14. So how we got the formula? So next, I will prove it. Next. Okay, so from do the how we prove it we choose Sn equal to 1 and Sn equal to 2. Okay, so first Sn equal to 1, 1 equal to 2, multiply with 45 plus n minus 1 d, multiply with 2. Okay, so 2 equal to 90 n plus n minus 1 d. Okay, so from that we can know that d is equal to 2 minus 90 n minus 1. Okay, so wait. Okay, so Sn for Sn equal to 2, 2 equal to 2 multiply with 48 plus n minus 1 d multiply with 2. So 4 equal to 196 n plus n minus 1 d. Okay, next. Okay, so from that we substitute 1 into 2. So when we substitute, we got n equal to 1 over 3 and d is equal to 1 to 6. Okay, so how we got the first formula? We substitute n and d in Sn formula. Okay, so when we substitute n and d with Sn formula, we got Sn equal to a over 3 minus 14. Okay, so how we get the decryption function formula. Okay, next. Okay, for the task B, we must we must uh, we must find meaning of this uh, of this meaning of this. Okay, so uh, go back to table. Uh, okay, so for from the table we can know the code is good job, you did it. Okay. Okay, so we go to task 4.
Okay, so I'm going to explain on how to solve the fourth task. So the question is, geometric series occur naturally in the solution of problems in finance. A geometric sequence with first term A, common ratio R, and n terms is given as follows. So the question is, find the sum of geometric sequence in equation 2 denoted by Sn. So the first step is I'm going to write it back as let A equal to our first term of n and big capital R as our common ratio. So based on the question, which is A and then AR and then AR squared dot AR's power of n minus 1, we could get that the sum formula is Sn equal to A plus AR squared plus dot and until plus AR power of n minus 1. That is our first equation that we could get. So to find the second equation, we will multiply the first equation with R. So we will get RSN equal to AR plus AR cubic, AR cube plus dot until AR power of n. So the next step, So the next step is we're going to let equation 1 minus with equation number 2. So we will get Sn minus Rsn equal to A minus AR power of n. How do we get A minus AR power of n is by minus everything that we could get from the equation, and then we will get A minus AR power of n. So then we will factorize Sn on the left side. Then we will get Sn multiplied with 1 minus R, and the right side we will factorize A. Then we will get A multiplied 1 minus R power of n. So we will take the 1 minus R on the left side to the right side. Then we will get the Sn equal to A multiply 1 minus R power of n over 1 minus R, which is R must not equal to 1 because the denominator must not equal to 0. Thus, by the equation from step above, we will get that Sn will be equal to A multiply 1 minus R power of n over 1 minus R when R is lesser than 1. And then we will also get Sn equal to A multiply R power of n minus 1 over R minus 1 when R is bigger than 1. So that is how we get the sum of geometric sequence for Sn. So move to the next task.
Okay, for task 5, given in the question is the we need to find the compounding factor, and the formula is 1 plus R. Given is the monthly interest rate, which is 1.75%. So we will substitute the monthly interest rate into the formula given, which is 1 plus R. R is the monthly interest rate. And then we will get the answer for compounding factor, which is 1.0175. So for task 6, the question as the monthly interest rate. So given that compounded monthly interest is 14.4%. So what is meant by compounding monthly is it is meant for interest for a year, per year. So in order for us to get monthly interest rate, we need to divide by 12, which is for a month. So we will get 1.2%.
And then we're moving on. After we got the monthly interest rate, which is 1.2%, we divided it by 100 because we want to get the decimals, the answer in decimals. And then we substituted into the R of the compounding factor, which is 1 plus 0.012, and then we will got 1.012. And then the last question is the final amount in the account after 25 years, or the. So the general formula for sum of geometric progression is Sn is equal to A R power of n minus 1 over R minus 1 as proof at task 4 before. Then we just substitute A, which is the first term, which is 350, the deposit, and then 1.012, which is the compounding factor, power of 300, which is n is denoted by months, which is 300. And then we divided it by 1.012, and then we minus it by 1. And then the total we got 1,101,565.10. The result from us. Thank you.